I'm Kate Nixon, a lecturer in chemistry at the Open University. My research investigates the electronic structure of molecules. It's the behaviour of a molecule's electrons that is responsible for most of the molecular properties. At the moment, we're hoping to use our experimental measurements to evaluate if molecules could be potential radiosensitisers for the treatments of cancer. In our experiments, we obtain an image of the electrons within individual molecular orbitals. But rather than looking at where the electrons are within the orbital, we find out their momentum, so information about how they are moving. We do this by using electron collisions, which is a little like playing billiards with electrons. A projectile electron collides with an electron within a target, and then both of these two outgoing electrons leaving the collision are detected in the experiment. This time-lapse video shows a day in the lab. A PhD student, Dave, and a postdoctoral researcher, Daniel, are working with me on the electron momentum spectrometer. As we only want to look at collisions with the molecules we are studying, the experiment needs to be conducted within a vacuum. We work at a pressure that's 1/1000th of the atmosphere that we live in. The vacuum is created in a steel chamber, and to do any work on the spectrometer, we need to lift the lid and access the spectrometer. In the first part of this video, David and Daniel are making sure that the analyzer is correctly positioned. They're using a metal rod to track the electron path from the collision to the electron analyzer, and making sure that the collisions reaching the analyzer are occurring at the point we have defined as the collision region. Small adjustments are being made to the analyzer mount to tweak the height and position. Finally, they need to check that the analyzer is detecting from the same position as it's rotated to different angles. And now it looks like it's lunchtime. One of the reasons I like working in this research area is because you get to design bespoke experiments to conduct the experiments that you want to do. This spectrometer is unique in the world and was designed and machined by researchers and technicians working within a university. This means that we can easily make modifications to it to do new experiments, to study different kinds of targets and collect different kinds of data. This research area allows you to learn new skills in apparatus design, both mechanical and electronics, how to control experiments like varying voltages and moving an analyzer as the data is being collected, and also coding skills to acquire the signals from the spectrometer and process it into meaningful results. And then there's the chemistry that we learn from these results also. Now the researchers are back and they are connecting the wires to the different elements of the analyzer, which will deliver a different voltage to each element. It's the combination of the different voltages on the electron lenses that focus and accelerate the electrons coming from the collision. It's important to make sure that all the voltages are being delivered to the correct element. Now it's time to lower the chamber and pump out the air to obtain a vacuum. It will be left pumping overnight before the spectrometer is turned on again. The work you saw David and Daniel carrying out on the inside was successful, so we were able to spend the next few weeks and months collecting experimental data. We compared our experimental data to theoretical predictions from colleagues in Australia and gained a better understanding of the electronic structure of the molecules we were studying.